G'day, Michael here. This video serves two purposes. One is as an introduction to the series, which I'm going to hopefully get a video every week on the subject. I've got a pretty hectic schedule, so I'm not sure how well I'll keep up with that. It's a complex subject for measuring for site. Some sites are simple, just square walls and that's it. But often you have complex situations where you might have curves to be measured. You need to have, when you're making anything to fit a site, you need to be able to reproduce a facsimile, quite a good facsimile of whatever the complexity of the shapes are. Hopefully I can insert some photos and some sketches and things of what I've been confronted with on site, and I can show over the series how to overcome what limitations there may be in measuring gear. Anyhow, this video I'm just going to introduce the hardware. Well, here's my box of tricks. There we go. Okay, you can see here I've already got some drawings. I've been out measuring things the last couple of days. Okay. So obviously what I need as a tradesman, I need to be able to show customers samples, need to handle some basic invoicing and so forth. I often receive emails with details on it. So I get records from a customer of their intent. That's always an important thing. If you've got a bit of an idea of your intent of the design, of course if you're making something for yourself, you may have a good ideas of what you're going to do. But in any case, so these three jobs, actually that belongs to that. So these are three jobs I measured up over the last few days. Now some very basic notes here. I've got, it's a pretty simple environment. You can actually see that there's a angled wall here, but it doesn't affect me. I've just drawn it in to let myself know when I come back to it that there's an angle involved. And of course the critical measurements are on there. I've got a little note here, is it ceiling height, 2396. And these are the various dimensions of the actual structure. Of course, for the customer, they need to see a bit of a sketch of what they're going to be getting. So this is a part of the kitchen cabinetry that's going to go into that space. This is another area. Oops, I'm upside down. Yes, I'm upside down. There we go. So this is the other wall. So you can see here on this side, that's where that angled wall comes off to the side. It's actually not drawn in, but that's what that wall is. The other drawing that I showed a second ago, which I'll bring back, shows from, where am I? From this side here. I haven't drawn these in the other view because they would be blocking the view of this cabinetry from the other side. So I do this with the customer so the customer can see what I'm thinking and I can see what they would like to see. And between us we get a quick understanding of what it would look like. Here's a simpler environment. These are, I don't know how well that's going to show up. These are wardrobes. Now they're very basic rectangular. There are no pipes for the wardrobes. It's just, flat walls. So I can actually just draw the cabinetry itself. So, you have to scale up and down the details you measure according to what the problem is at hand. This is an inclinometer. This is a laser measuring tool. Quite an advanced one. Of course, for a customer I have to have samples. Very important tools. A pencil case full of pens, pencils, eraser and that sort of stuff. Tape measure, which I'm sure everyone expects. That's probably the real workhorse of measuring. More samples to show customers what sort of bench tops and doors and so forth I can do. The box itself is actually part of my measuring kit, as in it's a measuring tool. What can happen, there's a bit of weight in this device and I've got a pretty square edge to work to. It is generally square with vertical sides. If you have something that's rounded and tapered, you can't use it in this way. But it gives me something, if I have to measure from somewhere to somewhere, I can use it as a tool to take a measurement from a random place around a room. So if I've got nothing else to measure to, it provides me a point of reference. when we deal with curved walls or where there's major obstructions, I'll be able to demonstrate the usefulness of a square box. Basically anything that's square and a bit heavy will be quite useful as a measuring tool, or sort of an anchor point for your measurements. Alright, so there's a tape measure. Now a very handy tool, but it's a bit technological. It's something I've had actually probably for more than a decade. One of the earlier adapters or adopters of these things. It's a laser, where are we? I don't know whether you can see that. It's producing a plane. I'm going to do that in a way that you can see it. Okay, you can see here there's a level line. It gives us a level line across a whole room. You can probably see, you can see that in the video. There's a level line here and here. What it allows you to do is run around with the tape measure. This one has, it's set, the laser emanates from the device at 100 millimeters. So I can measure over here, I've got 101 millimeters and then 99 millimeters. So this pack of board is sitting at a slight slope, but you can wander around the whole room. Now, the light, obviously the ambient light is a problem. Right here I'm close enough to the laser that it works fine. But if I have to go across the room, I'll just lift the camera up. And you can see it's even projected across to over here. So now I've got an ability to measure the height here. This is 715. And that's a reading 102. So I've got a reference to various planes along the way. Even here I can measure. And this height here is 480. So this is already giving me a reference in space for height. Now, it also can give me two vertical lines, this machine. So you've got a vertical line here with a crosshair. Okay, and that vertical line projects, as you can see, even over in a distance. You may already be able to see, I'll just move this a little bit into shot. Is that going to work? A bit at the limit. It's probably not light enough for you, so I'll kill one of the rows of lights. See if it makes it a little bit brighter. There we go. Yep. Okay. So now we have a plane running off in this direction, which is at a right angle to that direction. So you now have an ability to measure. I can measure from a wall to that line, which is here. I don't know whether it shows up. Okay, so we can measure this way, and then we can also measure at a right angle that way. I don't know whether that shows up, and am I blocking the vision? So we've got two planes to refer to. That is a very powerful tool for measuring if you've got some reference to a right angle, and of course, okay, the batteries are dying, but you can see the vertical line here and the horizontal. So we've got a number of planes introduced to our site, so we've got something to measure to. Very powerful tool. Turn those off. Put it away. Now unfortunately the laser measuring tool does not really work that well with the laser. It's basically a laser level, but it's better than a level. It's more than just a level. Okay, now this tool here measures, I'll just turn it on. In simple terms, it measures, you can see that dot. If I press measuring button here, it says, okay, 755 millimeters. And I found that even at sort of the 4 or 5 meter mark, it's quite trustworthy. Now, the advantage of this measuring tool, of course, it's very fast. Close to you, so you can see what I'm doing. I'll get a bit more light on. Okay, that's showing 755 millimeters. Now this particular device cost me about $800 back when I bought it. I'm trying to not have reflections. It cost me about $800 when I bought it. Now, there are cheaper ones on the market. Bosch make one. It won't have all the features that this does, but it's, probably better suited to someone that doesn't want to spend a big outlay. This here, I'm going to measure to that back wall over there. That's 14.35 metres. Now, a tape measure over that distance would be flopping around everywhere. That's if you had one that reached that far. And you probably need someone on the other end to hold it. And you'd be climbing over obstacles and around, and there'd be a lot of things between you and that measurement, and it'd be very difficult to take. Whereas for me, it was basically, if I can see a sort of a tunnel through to the location where I'm measuring, I can take that measurement. Possibly an example might be right here. I've often been in a situation where I'm measuring on site, and let me just focus that out a bit, where I'm measuring up someone's garage and they've just moved house, so the place is full of, packing boxes and things are piled a mile high, and you can barely see from one end of the room to the other. This lets me sort of take a measurement through a keyhole without having to climb through it. You can see the red dots showed up on the distance there. Press the button now. It takes that measurement. So even though there's obstructions between me and there's no problem taking that measurement. Anyway, I hope that's of interest to you. I think I've covered all those bits. Oh, one more. Aha. This is the inclinometer. I find this a very handy tool. It's basically got a spirit level and a knob it's got a kind of reduction transmission arrangement. Let's say we had an angle. I'll introduce an angle. Whatever that is. Okay, so you can see the device on this random little angle here. You wind it until you see the bubble that shows up in there, I hope. Until the bubble shows up level. That's pretty touchy around here somewhere. Quite a sensitive bubble. Okay, well I'm going to call that just over 12 degrees. I'm going to call it 12.1 degrees. But to read that more carefully, I'll bring that to you. So this is the scale I'm reading. You can see it's just over the 12 degree mark. Okay, it's fairly accurate. Just a bit over 12 degrees, as you can see. But you can see a different scale there. There's a gradient scale as well as the degree scale. So let's say we move that over to there. You can see the gradient versus the degrees. I'm sorry, it's back to front. It's not like a mirror with this monitor. So you can see how the scale would show the various angles. So you're able to see, let's say, the other thing you can do is go backwards. Let's say I'll set it to 30 degrees as best I can. Okay, so that's set to 30 degrees. So I can tilt it until that bubble works level. Now your viewing angle is probably a bit weird, but that's actually vertical in this, where it's actually vertical in this plane. I'll zoom out a tad. So I've got it vertical in this plane, and all I have to do is go to a point, and that sets me to 30 degrees. Obviously I'd have it on something stable. But I find it very handy for measuring things like staircases and handrails. This is a very handy tool for that. What I would actually be doing is measuring two kinds of measurements. I'll be measuring both the going in a staircase, which is the length across the floor, let's say, and then the rising, which how much it goes up. So you'd measure, the running length of the staircase across the floor, and then perhaps floor to floor, and that gives you your overall angle. So that will be very, very accurate. But I use this as basically confirmation. If this measurement of angle isn't pretty close to what the rise and going gives me, I can use that as basically an error check. Okay. Well, that's the end of this little video. I hope the video is of interest to you, and I'm hoping the whole series becomes of interest to you. Feel free to like, share, subscribe, make a donation, ask a question. If you have a particular video idea you'd like to see, let me know and I'll see what I can do. Bye for now.